Hey everyone, this will be the second video of my video series about drawing OSPF graphs. In this video, we're going to introduce type 3 LSAs, but instead of drawing the entire topology, we're going to show how a router will do recursion with the LSAs in order to get to a destination. And the reason we're not going to go through and draw the whole topology is because let me just go to R4, which is one of my AVRs, show IP OSPF database. If I went through every single one of these one by one, we would be here for 4 hours. So instead, let's go to R1, and I'm using the same topology that I've been using. So from R1 to R6, we're going to see how OSPF recurses to the destination. So what we're going to do is we're going to do a show IP OSPF database. And we can see now that we have three different types of LSAs. We have our type 1, which is our router LSA. So these are type 1. We have type 2, which is our net link state. And now we have type 3. And this is because we're doing inter-area routing. So what we could do is in the OSPF database, instead of doing a show IP route for 6.6.6.6, instead, let's do a show IP OSPF database for the summary. All right. Now we can see we're actually getting two LSAs. And if we scroll back up, we could see that here as well. We were getting two. So, whoops, sorry about that. The first one is here. And the second one is, here. Now, they're both very similar. They just have a little bit different information based on the advertising router. So this one is advertised by 4.4.4.4, and this one is being advertised by 5.5.5.5. And in both cases, the metric being advertised is 2. So what we can do is to start our drawing. Let's say we have our 6.6 route, and now we have two routers that are advertising them, 2 and 2. So this is going to be 5, and this is going to be 4. Excuse me. So this is going to be 4. Okay. And just to show you, actually, we'll first do the recursion, and then I'll show you a command where we could have actually found this information out a lot quicker. But what we'll do is the advertising router is how OSPF does the recursion. So for the first one, we see the advertising router is 4.4.4.4. So what we do is OSPF looks in the database for the router 4.4.4.4. From there, it sees, oh, okay, I have one link to a transit network, and the metric of that is 1. So here's router 4. I have one link to a transit network. I have 1 as my metric. This is my DR of the transit network. And that's it for 4. If we go to 5, on 5 we could see that in area 0, we have this point-to-point link, which goes to the neighboring router of 2, again, with a metric of 1. So let's go ahead and draw router 2. And we have a metric of 1. So now we can go to either spot. We can go to either 2 or the DR. Let's go ahead and take a look at the DR because there's something interesting here. OSPF database network. And the network is 10.0.234.3. If you're wondering where I'm getting that from, that's up here at the top of the screen for the designated router address. And we can see we're connected to 3 different routers. I'll draw the link for the DR to 2. And you'll notice that in here, I don't see the metric anywhere. And the reason being is because let's say we went over to R2. 2.2. The metric up here to the transit network is also 1. So if we put 1 in here, by looking at this, you would think that the metric to get from 2 to 4 is 1, but that's just not true because the DR is a pseudo node. It's not an actual router. The metric between 2 and 4 is 1, not 2. So this is one of the cool things that the database does is that when it's DR, it doesn't add these metrics together. It knows that, hey, if both of them are 1, that means that the metric to get between them is 1. So we could take out 1 there, and let's head over to R2. All right. And from R2's point of view, we could scroll through and we're looking for our point-to-point link to 1, which is us. So the final thing we could do is go from R2 to us at 1. And again, we could see that the metric there is 1. So let's go ahead here and 1. So just looking at this diagram, we could tell a few things. One is that we're learning about 6.6.6.6 from 2 different ABRs. And 2, we could do some quick little, the math isn't very hard, it's just simple addition to see what our metric is to get there. So first, we could take a look at the ABRs. And let's see what the metric is to get to each one. So from the path 1 to 2 to 5, well, it's 1 plus 1, and it's 2. So to get to 5, the metric is 2. Then from 1 to 2 to 4, well, again, 4 equals 2. So we should be equal cost load balancing between those 2 ABRs. And a quicker way, so instead of us drawing out this diagram, we could have used the show IP OSPF border routers command. And sure enough, if we take a look at this command, we could see that we have the 2 border routers, and both of them have a metric of 2. So this area OSPF border routers command is a great command when you're trying to look in inter-area or even an external OSPF route. Now, the final math that we could do is to get to our 6 network. And this math, again, isn't much harder. So we know that to get to the border routers, it's 2. And then from the border routers, they're advertising a metric of 2 to get to 6. So for both paths, our metric should be 4. And that was some awful drawing. So instead, I'll just put a line. That should be our metric. So let's go ahead and show IP route 6.6. And sure enough, if we look at the bottom, route metric is 4. So this is how we use the graph theory in OSPF to not only calculate the metric to a route, but also calculate how OSPF should be getting there. Now, from our one's perspective, if we do we do the show IP route 6.6.6.6, we can see we only have 1 path, but that's because our next hop is 2. If we go to 2, here we could see both of our routes from ABR 4 and from ABR 5. So this is how OSPF does recursion with type 3 LSAs. If you have any questions or comments, please leave them below. Thanks.